Okay, pre-cal, these are going to be some practice problems like you'll see in your homework on MathLab. First of all, we have find the standard form of the equation of an ellipse with foci at -2, 0 and 2, 0 and vertices. And when it says vertices here, when you read that on MathLab, it is talking about the major vertices. I usually say major vertices just as a way to differentiate them from the endpoints of the minor axis. So foci and major vertices are given here. So the first thing I'm going to do is I'm just going to draw myself a quick diagram. So don't be lazy. It doesn't have to be perfect, but draw yourself a quick diagram so you understand and can see the orientation of the information that's given. So back 2 up 0 and over 2 up 0. And we have back 3 up 0 and over 3 up 0. So what does this information represent? Well, what we learned in the intro video is that here is our A value. Our A value is the length of the semi-major axis. So A here is 3. And then the other thing that we learned was the distance from the center point to a focus is the C value. So this is our C value. So C is equal to 2. Now obviously we have our center point this time at the origin. So based on the information that I can see here, I'm going to go ahead and start writing out things that I know must be true. So HK is 0, 0. A is equal to 3. B we're going to find in a moment. C is equal to 2. So this is everything I know so far. Now, I do know a relationship of A, B, and C within the ellipse. Within the ellipse, C squared is equal to A squared minus B squared, not a Pythagorean relationship here. So 4 equals 9 minus B squared. So B squared equals 5. Therefore, B is root 5. So the square root of 5 is approximately 2.23. Now, we want to know that just for the purpose of being able to graph this as realistically as possible. So the B value is the length of the semi-minor axis. So if we go to that origin, which is our center point here, and we go up 2.23, which we'll say is about right there, and down 2.23, which is about right there, then we can see our B value. So here's our B. Our B value is root 5. So that's going to allow us to draw in our ellipse. We'll do that in pink. And remember, the foci are in the interior of the ellipse. These are our vertices on the end, and these are kind of challenging to draw sometimes. They're not going to be perfect. They might look like an egg or a potato. That's okay. So there's our ellipse. So our B value was root 5. So we can see here that this has a horizontal major axis, and when we have a horizontal major axis, our general form looks like this. It is x minus h squared over a squared plus y minus k squared over b squared equals 1. That is the given general form. You need to know that. So let's plug in and let's write the general form of this ellipse. Okay, so x minus 0, and we'll just plug in everything so we can be sure to see everything here, over a squared, 3 squared is 9, plus y minus 0 over b squared, b is root 5, therefore b squared is 5, equals 1. And we can just tidy that up, get rid of those zeros because x plus 0, 0 is the identity, so x squared over 9 plus y squared over 5, and that is the answer to the first one. That is the standard form of the equation of an ellipse with foci at negative 2, 0, positive 2, 0, and major vertices at negative 2, 0, 3, 0. Next, going in the opposite direction, graph the ellipse and give the location of its foci. I'm not sure why I wrote the word given. Well, given this equation is. So let's look at what we've got here. So first of all, this one appears to be different from the last one because b is 2, or I should say b squared is equal to 2, and the a squared is equal to 5. But notice that a squared is underneath the y in this situation. So a squared truly does represent the major axis. This time we have a vertical major axis. Why? Because a is living underneath y. So that's something to point out here. So if we have a vertical major axis, and remember, this is addition, and addition is commutative, so it really doesn't matter. I'll write it in a different order just to make that point. So y minus k squared over a squared plus x minus h squared over b squared equals 1. So this is if we've got a vertical major axis. So let's write down what we know so far. So we know our center point is at 1, negative 3. We know that a squared is 5, b squared is 2. C squared equals a squared minus b squared, so c squared equals 5 minus 2, c squared is 3. Therefore, c, not approximately, c is root 3. And remember, c has everything to do with finding the foci. Okay, so let's go ahead and graph what we know so far. So our center's at 1, negative 3. So over 1, down 3. 1, 2, 3. And you'll notice, I mean, obviously, I knew where the center point was going to be, which is why I skewed the way I drew these two axes. So graph paper can be helpful, but sometimes it doesn't always put your center point in the best location. So let's keep going. All right, we know that we have a vertical major axis. We know that a squared is 5. So the square root of a, or excuse me, square root of 5 is what a is going to be. And the square root of 5, 2.24. So we are approximately 2.24. So that's square root of 5. So from here up and about there. And then down and about there. So these are our major vertices. The square root of 3, 1.73. So if you remember that from all our trigonometry, so 1.73, pay attention here, 1.73. So vertex, focus, center, focus, and a vertex. So those are just helpful to remind you what's going on there. And of course, all of that is our major axis. Our minor axis, so b squared is 2, therefore b is square root 2, and the square root of 2 is 1.41. So 1 and some change, 1 and some change, so that is a minor vertex, and that is a minor vertex. So here's what our ellipse is looking like. Draw it in pink. Remember, it's got a nice curve. This one is a bit more elongated. And if we were to be reminded of eccentricity, how ovalicious our ellipse is E is equal to C over A. It's a ratio of the C value over the A value. The C value is √3. The A value is √2. So basically, we've got an eccentricity of the square root of 1.5. Square root 1.5. So not very ovalicious. Remember, if the foci converge upon the center point, if the eccentricity goes to 0, then we have a circle. So let's see here. Probably, we need to give the location of the foci, so let's do that. And the foci have everything to do with C value. So if our center point is at 1, 3, then our foci, and think about it, this H value is not changing. It's not going to change. Everything is located on that major axis, which has an X value the same as H. So the H value is not changing. So our foci are going to be at 1 and then -3 plus √3 and 1 and then -3 minus √3. So we've graphed the ellipse and we've given the location of the foci. We have answered the question completely. Find the standard form of the equation of each ellipse satisfying the given conditions. So we've got some given conditions here and we need to graph this information. So I've got our axes all set up, ready to graph here. So endpoints of the major axis. So basically these are major vertices. So over 7, up 9. I'm going to get my handy ruler here to be sure I'm kind of lining up things straight here. Over 7, up 9. So there's 7, 9, and then also 7, 3, which is about right there. So those are my endpoints of my major axis, so those are vertices. Then my minor axis, over 5, up 6. Let me get it lined up here as best I can. And then over 9, up 6. Pretty good. So here are all the vertices of our ellipse. So let's think about what must be true here. Well, where these two axes intersect, of course, is going to be our center point. So our center point has to have an H value of 7 and a K value of 6. Over 7, up 6. It does. So I'm just extrapolating what must be true based on what's given here. So we've got an HK at 7, 6. So let's start thinking about what our A value is. Remember, our A value is the length of the semi-major axis. And in this case, this is another vertical major axis. Our B value is the length of our semi-minor axis. So we have 1, 2, we have a B value of 2, and then an A value that goes from 6 to 9, so an A value of 3. 1, 2, 3, 1, 2. There we go. So A equals 3, therefore A squared equals 9. B equals 2, therefore B squared equals 4. And C, remember, C squared equals A squared minus B squared. That's a given formula for the A value, the B value, and the C value, not a Pythagorean relationship. So C squared is going to equal 5, therefore C is √5. And yes, we have the same numbers that kind of crop up over and over again when we're doing these problems. So, okay. We know A, we know B, we know C, we know H, we know K. We can go ahead and we can write the equation of this ellipse. Remember, that's what it asks for. Find the standard form of the equation of each ellipse satisfying the given conditions. So here we go. So once again, this is a vertical major axis. So y minus k squared over a squared plus x minus h squared over b squared equals 1. Too much power. So plug in what we know. So y minus 6 squared over a squared over 9 plus x minus 7 squared over b squared, which is 4, equals 1. So that's our standard form. Now, I'm going to go ahead, draw it in, because we want to be as thorough as possible. Let's go ahead. Let's find the location of the foci. Let's find the location of the foci. So our C value is root 5. So once again, C is living on this major axis. So that means our H value will not change, only our K value. So 7 and then 6 plus root 5, and then 7 and 6 minus root 5. Root 5 was 2.24. So up 2 and a quarter, so there's a focus, and then down 2 and a quarter, about right there. So vertex, focus, HK, focus, vertex. There's our ellipse. This is our standard form of the equation, and these are our foci. Last problem for this video, just reminding you again, eccentricity measures how ovalicious an ellipse is. And eccentricity, here's the long-winded formula, but basically it's just the ratio of the C value divided by the A value. So write an equation for the ellipse having foci at -2, 0, +2, 0, and eccentricity at E equals 3/4. So if E equals C over A, all right, so these are the things that we've got to use, and it's still helpful to just quickly give yourself a little more information here. So I am just going to free-handed draw what's given here. Think about this. Back 2 and then over 2, remembering that the foci live on the major axis. And the midpoint in between the foci, of course, is going to be our HK. Now, I'm drawing this quick picture to give you a little bit more information to remind you that this time we don't have a vertical major axis, we have a horizontal major axis. And if we have a horizontal major axis, our standard form is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. So we know that our HK is at 0, 0. But here's the other thing we know, and we haven't even used this yet. We know that C equals 2. C equals 2. Remember, the C value is the distance from the center point to a focus. So we know that C equals 2 based on the location of the foci. So if C equals 2 and E equals C over A, and our E value is given, 3/4 equals C over A, and we know that C is 2, so let's let that be 2. So 3A equals 8. Therefore, A equals 8/3. So if A equals 8/3, then A squared equals 64/9. B, we shall find momentarily. C equals 3, or excuse me, lost my C value. C equals 2, therefore C squared equals 4. So we need to use these two values because here's what we know, and I'll draw a little box here for us to work in. We know that C squared equals A squared minus B squared. So 4 equals 64/9 minus b squared. So if I quickly multiply everything by 9, so times 9 times 9 times 9, I get 36 equals 64 minus 9b squared. That dumps that fraction very quickly. So 36 minus 64, and I'm using my calculator because subtraction's hard. 36 minus 64, 28, okay? So 28 equals 9b. I'm dumping my negative signs there. So b squared equals 28 over 9. So b squared equals 28 over 9. B, of course, would be 2 root 7 over 3. I'm not even going to attempt to graph this. I'm just going to write my equation here. I think I need a little more paper here, so I'll just add on what I've got down here. So here's what we're doing. Let me circle everything that we're about to use here. I need to know a squared, I need to know b squared, I need to know hk in order to write the standard form of my equation. Remember, having foci at negative 2, 0 and positive 2, 0 and an eccentricity of 3/4. So here goes. And there's my standard form. So x minus 0 squared over a squared over 64 over 9 plus y minus 0 squared over b squared, which is 28 over 9 equals 1. Now, that is certainly not showing your good algebra manners. So recall that when we divide by a fraction, it turns into multiplication by the reciprocal. So the very best answer is, and of course x minus 0 is x, so we've got 9x squared over 64 plus 9y squared over 28 equals 1. There's your very best answer for an ellipse that has foci at negative 2, 0, 2, 0, and an eccentricity of 3/4.